Alright, in example 4, we're just going to do one of those informal proofs again. We're given that MP is congruent to NS. So here's MP, this whole thing is congruent to NS. Then we're told that O is the midpoint of MP, so anytime you're given a midpoint, that means that you have congruent segments. And then we're also told that R is the midpoint of NS. So because we know that MP and NS are congruent, if you have midpoints in both, then those are going to be congruent, the same congruency marks. Alright, so what conclusion can we make based off of this? Well, looking at the figure, it looks like we have a lot of congruent segments. So we can conclude that MO is congruent to OP, which is also congruent to NR, which is also congruent to RS. And why are we able to make those congruency statements? That comes from your division property that we went over in the last video. And division property says if segments are congruent, their divisions are also congruent. So we started out with congruent segments right here, and then we put in a midpoint which divides it into congruent segments, so the divisions will also be congruent.